So I wanted to use Python to control cloud infrastructure. And some of the reasons as to why. Well, I like IDEs. They do things like auto-completion. They do things like allowing me to check for syntax errors. They do things that basically keep me from pulling my hair out, slamming my head in the desk, and running away screaming. I like to do things programmatically. So this means being able to check for state, understanding what I just did it work, did it not work, how do I want to react to that? And I hate YAML, as covered in the previous slide. Why Python specifically? Because it's amazing, but mostly because it's what I've been working with for the last number of years. So today's goals. We're just going to go over some code. This will not be a live demo. There will be pieces of it I can live demo if we choose. But the goals are to create an instance using Python, and then I want to associate it to a load balancer. This seems pretty straightforward, and I picked this goal because it could be, quite frankly, done in a number of lines necessary to fill the screen. So we'll get an example. So what are the options we're going to work with today? Bodo, which is AWS owned and controlled Python library for controlling Amazon infrastructure. libcloud, which is an Apache project. It's cloud agnostic. It attempts to try and make it so that if you write code to work with Amazon, you can also turn that same code and point it to Azure, and it will work the same. And then our product, DivvyCloud, because, well, I can. So what is Bodo and the pros and cons of it? So the pros are that it's really easy to use. Who here, we had some programmers in the audience, have you ever worked with an object relational model, an ORM? Yeah. So one of the things that Bodo does that's really interesting is that it's a little bit more of an object model, and that it sort of keeps some state. So when you spin up a server, it provides you back a Python object, which later you can check the state on. And then if you call .update on that object, you can check the state again, and it will have changed. So it provides some transitional state, but not a lot. When I say it's some, I mean it's not going to maintain from one script run to the next without re-updating all of its data. It's well documented. I was actually sort of, to be perfectly honest, you're writing this code about an hour and a half ago, and noting the documentation was actually pretty well, so here it is. Up to date, maintained by AWS, which is great. Downside, it's AWS only. So if you write your tools for this, you better be prepared to stay in Amazon, or else you're going to have to retool. Its simple operations can be rather slow at scale. So if you have to do a large number of operations across a large number of systems, say 10,000 VMs, it's not exactly the speediest thing. And there's no secure key storage. So that basically means that you have to store your API keys in Amazon. I should probably have asked this before. Who here has worked inside of cloud infrastructure like Amazon and like that? Sweet. So the API keys can get stored in like a configuration file, but they're not encrypted, they're not in a database, they gotta be on the same system. Maybe they can be environment variables. You can wrap it and do it yourself, but as out of the box, that's not what it provides. So an example of the code. I will walk through this code as best as I can. So really at the end of the day, the goal was again to provision an instance and associate it to a load balancer. So you can see the first two things I have to do is create these two objects, one for ELB, load balancer, one for EC2. And then I create an instance using a specific AMI. I name it using my key pair name, or I may be able to connect to it with my key pair. Specify the instance type, security group, and subnet. All pretty straightforward stuff. Then I do an instance reservation, gives me back an object, and you can see I have a print line, instance is created, but now I have to wait for the server to come online. So this actually touches a little bit on what Alex was talking about. It's asynchronous, right? Cloud infrastructure, when you create it, is asynchronous. You start a server, that server may or may not be online sometime in the next 60 seconds, depending on how many servers you provisioned at once, depending on any number of things you've done. Same thing with applying like tags. In some cases, if you provision 100 instances inside of Amazon and try to apply tags to them right away, it will fail, because the instance has to reach a certain state inside of Amazon in order for tags to work. So you end up in this sort of chicken and egg thing where you're like, well, I spun up an instance, but I need to know when it's actually available for me to do something with. So in this case, you see I create a simple while loop and checked for its state. If it's in pending state, meaning it's still trying to start, I'm going to wait 10 seconds. That's really amazingly complex code. What is interesting is that you see there the instance.update, and this goes back to that ORM concept. By calling update on the Python object instance, it will go and Bodo will go and get the update state of that instance and update data, put it back into the object, and I can check the state again and see if it's running. Once we break out of pending state, I then associate some tags, pretty straightforward. Again, that is asynchronous. So this is a race condition by default. The second that actually gets executed, I'm on to the next thing, but that does not mean tags have actually been applied yet. It means Amazon has received the command to apply tags. That means it could be anywhere between 5 seconds, 10 seconds, 20 seconds, if ever, that it actually gets applied based on what could or could not have happened inside of Amazon at that time. I can tell you that when you're dealing with like 20 servers, you will not see a mass number of failures. When you're dealing with 4,000 instances at once and you're creating 4,000 all at the same time, you will see failures. You will see tags that don't get applied. You will see instances not show up properly. You will see those things happen because Amazon's using eventual consistency on its database backend. It will eventually become a consistent thing, maybe. So when you get into scale, it becomes a little more challenging to deal with these types of problems. While it looks very simple here. Then you see that I get a list of all load balancers, I find the one I'm looking for, and then I register the instance with the load balancer. So in this little section of code, I was able to create an instance and immediately associate it with a load balancer. So this is really interesting because you can see the reverse of this, being able to tear it down. And you can be able to see, watching your infrastructure to see what's changing so that you can tear it down. You could re-implement all of AWS's auto scaling using Python. And this is really interesting because utilizing something like that means you make the decisions about when you scale. Not how many queries am I getting to my load balancer. You make the decisions by how bogged down is my application? How fast am I able to do database queries? Those things really drive the decision to when you scale. AWS's auto scaling is all driven or mostly driven by load balancer. You can do some other events and alerts, but for the primary purposes, that's what it's driven by. Unless you're using their RDS. If you're using all of their other tools in the ecosystem, you get a little bit better. So, takeaway, Bodo is super easy to use. It is Amazon only, and it is a library with a sort of ORM style feel, and that it allows you to get some state. So those are the takeaways from Bodo. So the second one is libcloud. This is an Apache-based product. Pros, it's cloud agnostic. So if I make something for AWS and then point it at Azure, it works. It's community driven, so the upside here is it's not owned by a company. Meaning that if something you want has not been implemented, you can go implement it yourself, or you can wait till somebody has the same problem and implements it themselves. It's kept up to date pretty well. We know the developers of libcloud, they keep it up to date pretty consistently. Has some cons. It does not have as deep support across the board. So, for example, it'll support an instance or a server across most infrastructures, but it may not support load balancers across all of them. It may not support S3 style objects across all the different cloud providers. So it's going to vary on its support based on who has built that driver and what their goals were. Again, simple operations can be slow at scale. It's doing a lot of checking and rechecking, or manually you're going to do that because you don't have that ORM concept or style concept you had in Bodo. So what you'll see when we look at the code is there's a lot of like, I'm going to go check and recheck and remake those calls to make sure things are as I expect them to be. Again, no secure key storage, but even more so, there's not, to my knowledge, and Chris may be able to validate this, but I wasn't able to find it, there was no config file. Bodo provides like the ability to put your keys in like your home directory and a .bodo file, and it'll just find them. Apache does not appear to have that. It allows for environment variables, but I don't think it allows for any configuration files. Is that accurate?
It doesn't actually, with Google Compute, it actually writes the credentials to a flat file on disk, which the permissions are not secure. So if anyone gets on that system, they have credentials right into your Google Compute account, which is not shit, obviously.
Yeah, I mean, it's no bueno.
Yeah.
What we're seeing, and one of the things we definitely look at is when we look at these libraries, a lot of them don't provide that key storage, which means you end up having to do it yourself. Either securing it through a sort of a wrapper or some sort of database and encrypting it there. You end up having to sort of maintain that yourself. That's not too terribly big of a deal, but it does mean it's something you have to worry about. Unfortunately, with the sort of a lot of the fast-paced development that goes on these days, and people, I mean, I love Docker and using Docker is great, but sometimes what you'll see is people will build like Vagrant images, and then they'll put the keys on the Vagrant image itself, and then they'll deploy the Vagrant image, and all of a sudden that Vagrant image has API access to your entire Amazon environment, which is awesome. And that's the types of things you run into when you look at some of these things. So a little bit more code to sort of get the same job done. I will say that I got to work with this for about an hour before giving this presentation. Their documentation sucks. It's really bad. It does not align with what you're actually supposed to do to make things work. So I ended up having to read a lot of code in order to understand what was actually happening under the covers. to pass in even the correct arguments for things. You can also see a couple of things that are different in this. Number one, it's a little more difficult to create these drivers, a little more programmatic. You can see that in lines 20 through 22, I'm having to go get all that data, like sizes and subnets and all stuff, directly from Amazon. Do I need to make this bigger? Can I? Oh God. Oh God. Oh no. Oh no. We're back.
Also, do I have to go revoke those keys like right now?
You do.
All right, sweet. No one take.
So this is pretty awesome, by the way. Apparently Zoom only functions on the elements around it, so that's pretty cool. So anyways, we'll just go with it. So if you can read this, you probably can't from out there. Lines 20 through 22, I'm basically getting a lot of data from Amazon. I'm getting subnets, I'm getting sizes, I'm getting images. So these can be hefty calls. For example, the get image call. Well, I happen to be calling on our private images, which means it's pretty small. We have 10 private images. Chris, do you know how many public images exist inside of Amazon?
150,000.
It's a fairly significant amount of data to pull down, go through, just so you can create your image object. So that's a little bit painful and a little slow. Obviously, it doesn't scale. And then you see you have to do some nonsense to pull out the sizes and subnets based on their IDs, so on and so forth. Create the node, pass in the image. Again, similar structure, passing in the image ID, passing in subnet. And then there's an interesting thing you see here, which is the driver wait until running. So libcloud took it a little further, made it so I didn't have to create a while loop to wait for it. It provides me sort of a pause mechanism, but again, sort of kludgy. Again, I'm going to pause everything in my application unless I'm threaded to be able to handle that particular wait. So in Python, since Python is sort of threaded, you can spin this off into a thread and be able to wait for the recall that back way. I'd be able to wrap that up in a callback mechanism and be good. But nonetheless, a little kludgy. Then as you can see, the server comes online, because I have to wait for the server to come online before I associate with that load balancer in order for it to be effective. And then I have to go find the load balancer in question, and then I need to go and associate it. So again, same stuff, a little more code. As Chris just pointed out, keys are right there in the open for whoever wants to modify this file or take a picture right now.
It's already on Twitter.
Cool. So as you can see, it's a little different. But again, not a lot of code. Realistically speaking, if you're familiar with Python, it's not terribly hard to pick up. In this case, the documentation is no good. So it's a little bit harder. So be it. So what are the takeaways here? libcloud is a true library. Shocker, libcloud. It doesn't have any stateful concepts built into it. It's cloud agnostic, but I would not say it's for the hobbyist. If you're just going to play around, go use Bodo. If you plan on doing something like a tool that's actually going to use multiple cloud providers, I'd recommend maybe libcloud, but be prepared to have to read a lot of their code to make sure that things are aligning. If you go to their docs site, you will see on one documentation it says to do it this way, and you go directly to a linking on that thing, on that documentation, to another piece of documentation, and it'll tell you to do it a different way. It's awesome. So that's libcloud. So DiviCloud, our product. So we're only going to demonstrate this because of the point trying to drive home with the asynchronous stuff. Really, at the end of the day, the pros and I'll speak openly about our pros and cons. We are cloud agnostic. The one primary difference is we are a platform. We're not a library. So what that means is that there is a little bit more of a learning curve and steep curve in getting the product set up. Because it is really more of a platform base you're building on top of. It does provide for the secure key storage. It's also a service and an SDK, meaning that it actually runs a RESTful service. So if you want to utilize a agnostic REST API, you certainly can. And it's asynchronous. So what you'll see me demonstrate here in a little bit is utilizing that ability to make the code a little cleaner and a little easier, because I'm not having to wait for certain things to happen. I'm not having to go get a list of things because I don't need to do that anymore. And we'll explain that in a moment. It has some cons. Like libcloud, we don't support every single cloud as deeply as we'd like. Documentation is also lacking, but at least the pieces we have are correct. Not intended to be for simple scripts. Right? If you're going to go and spin up 10 servers for fun and see what you can do, Bodo is probably the right option. If you plan on running an infrastructure and building an enterprise-based infrastructure and programmatically creating it, we may be the better option for that. So the code, as you can see, is a very different structure. And the primary reason for this is because of some of the things I talked about earlier with that need to wait and not having context. So what I mean by that is, in the earlier examples, when you create an instance and then you associate the instance later, you sort of had to keep all that around and then understand everything about the instance and go get all the information about the instance. In this example, what you're seeing is this load method goes and finds the organization service, which is part of the platform. Because we provide, you can think about this as looking up the key pair. Because we provide a secure key storage, this looks up the key pair for you and creates a connection to the cloud provider so you don't have to worry about that, and it's done sort of behind the scenes. We then get a gateway to a specific region for that particular provider. Again, it's agnostic. In this case, we're using US East 1 for Amazon, but it could be any region of any cloud that you are using our system for. You will see there's a bug where it indents, and Python will p itself, but in this case, what we're going to do is create an instance. Same type of mechanism here. Name, size, image ID, subnet. The one thing you'll note the difference between Bodo, libcloud, and us, we're a little closer to Bodo, and then you can just use strings in libcloud whenever you want to do something like get an image, you got to create the image object, which either means going and finding it from Amazon or creating it manually. So it expects everything to be very object-driven. We do allow for strings, so that it makes it a little easier to work with. In this case, you're going to create an instance. So now we're back to that part in the other code where I'm going to wait for the instance to be created. In our world, what we decided to do is make it asynchronous. So you see at the top of line 12 there, we've created what we call a hook point. This is basically registering for, hey, let me know when an instance has been created. So in our world, what an instance created means is that an instance has actually been created in Amazon, and then later on when our platform is doing some data harvesting and looking around, it discovers this instance has been created, and it lets the system know, hey, the system's actually there. It's actually in Amazon right now, and it's actually in a state. We have a couple different ones, created, modified, and destroyed, so you can register for any of those. In this case, I just register for created. The object that comes in there that I've named instance is actually just for being able to talk about it, but actually that object that you get in represents whatever resource you happen to have created. So if we had hooked into DivvyCloud instant or volume created, this would call that, and the resource you get passed in is an object representation of a volume. In this case, this is an instance. You can see that I checked the name like I did in the other ones to see if it's in DC hamsters. And then I go get the load balancer based on the name, and then I associate the instance to the load balancer. It's a little more compact because I don't have to do that waiting around for when the instance was available. I'll just get told when it's available. This type of what we refer to as event-driven programming, very similar to the way JavaScript does a lot of its things as well, is really beneficial because it shrinks the amount of code you have to worry about and allows you to focus just on what you're trying to do as opposed to focus on maintaining state, which is a lot of what you do in some of these libraries of programming. So that is an example of how the same operation can be done here. Again, takeaways, it is a platform. So you do have to commit to it a little bit more than you do other libraries. You stand it up, you add your keys in through a web interface, and then from that point forward, you sort of utilize it as a platform, build plugins, extensibility, and SDK through that way. It is cloud agnostic. Downside, it is not open source. It is a product that we have to make money off of. But today, sometime in the future, we may be open sourcing our core platform, but as of today, it is not. So, takeaways. So lots of different options out there for controlling infrastructure with Python. Varying levels of complexity. It is, depending on what you're trying to do, you need to pick the right tool for it. If you're just trying to get a list of all your instances in your Amazon environment, use Bodo. It's easy. It's done. If you're trying to do more complex scaling, and auto-scaling and sort of automation, a platform like ours, like Delta Cloud or DivvyCloud, would also work. And then libcloud is really geared for if you want to do something mildly simple, but cloud agnostic is really a key part of what you're trying to do, libcloud also might be a good option. The event-driven infrastructure concept we hope begins to take on inside of other libraries. We don't want to be the only ones really out there trying to do this. Because at the end of the day, it really is about building infrastructure programmatically and utilizing things like Docker to automatically deal with the entire environment. In a world where Docker can be a single instance you're going to deploy everywhere, and then you have a platform that is aware of the infrastructure, load balancers, instances, security groups, volumes, network access lists, everything essentially from the infrastructure perspective, you can begin to truly programmatically build an infrastructure. You can begin to actually really truly manage 10,000 VMs with 2 people. And it's because everything else is being done programmatically, not through some strange JSON component or YAML. It's a language that you're familiar with and you can work with that has been around for a while. And then, of course, there's a lot more work to be done in this area. libcloud is always accepting people to contribute back to that library. Bodo, I don't know if they take pull requests. And given that we're not open source, you're welcome to write code for us for free, if you would like. See any of us. But there is much work to be done in general across this space. I think people are really just starting to turn on to the idea that it can truly be programmatically built and managed. And by doing that, you wake up less in the middle of the night to deal with problems. A programmatic infrastructure that can detect when a volume is actually getting full and do something about it, as opposed to just sending you an email saying, hey, you're going to have a problem in 5 minutes, you should get out of bed, would be an ideal world. So that's really what we're gearing towards, and that's what this whole infrastructure as code meetup is about, is to try and identify more ways that we can control infrastructure with code.